Alright guys, lesson 8.5 is over properties of trapezoids and kites. Two little polygons or quadrilaterals that we're going to be working on, and that's it. Going through their characteristics. Now these do not classify as parallelograms. That's why they were not with all the other quadrilaterals that we studied up to this point. A trapezoid has one pair of opposite sides that are parallel. So right here, and we call these sides our bases. Okay? So these are our parallel sides, and they are referred to as your bases. Okay? Then you have something called an isosceles trapezoid. Your isosceles trapezoid is like an isosceles triangle. You have two sides that are congruent, and therefore those angles opposite those sides are congruent. So it kind of that's why it uses the term isosceles. So you've got one pair of opposite sides that are parallel. These are your bases. Okay, and one pair of opposite sides that are congruent. Now your parallel sides are not your congruent sides. Keep that in mind. Okay, now these sides opposite, well, you can kind of go two ways with that. You've got what's called your not necessarily your base angles, but you've got your two pair that are acute and your two pair that are obtuse. Right here, these angles are both acute. They are going to be congruent. Here you've got these two angles that are obtuse, and they are going to be congruent. Now, one thing to keep in mind, just like your parallelograms, your your consecutive right here, your obtuse and your acute are going to be supplementary. So let's say this angle here is 110 degrees. So this angle over here is going to be 70 degrees. Therefore you've got 110 plus 70 equaling 180. And it's going to be the same way over on this other side. Now, consecutive this way, no, those are your two obtuse angles. There's no way they can add up to 180, nor can these two acute angles add up to 180. It's your acute and your obtuse. All right, one formed from one base and one formed from another base. To make a note, the one pair of opposite sides that are congruent are called the legs. And that's just like in an isosceles triangle. The two sides that are the same are called legs, and the third side is called the base. It's the same way here. You've got your two bases, and then you've got your two sides that are congruent. Those are your legs. So let's go ahead and label those. There's a leg. Here's a leg. Here's a base, and here's a base. All right? Now, some things about your diagonals of an isosceles trapezoid. Both diagonals are congruent, and this has to be in an isosceles trapezoid. Not any trapezoid. Wouldn't be the case here, but it is definitely the case when it is isosceles. Okay, so these your diagonals are the same length. So what I want you to note, they do not bisect each other like in parallelograms. Not at all. You've got this diagonal, which we're going to say is 12 inches. And then you've got this other diagonal, and its entirety is 12 inches. And notice I extended the line all the way down from angle to angle. Make sure you know that, and it's not just here at this point of intersection. It's the whole thing. All right. Then, last but not least, on the trapezoid, you have a mid-segment. We discussed mid-segments a long time ago, last semester. And remember, a midsegment extends from one midpoint to another midpoint. So a midsegment, if this is a midpoint, then on this side right here, these two sections are congruent, and over here, these two sections are congruent, and they are congruent here as well, because these two sides are congruent because it's an isosceles trapezoid, and if this is a midpoint, then these two are congruent to each other as well as across. Okay? Now, because we have a midsegment is also parallel to the third side in a triangle. But this is in a triangle, it's a trapezoid, but it is parallel to both of the bases inside the trapezoid. And I want you to take a look at this. If you were to draw and continue these sides, just think of it this way. You would have made a triangle. So isosceles trapezoid is an isosceles triangle with the tip cut off. Okay, so all the same rules still apply for it that do in an isosceles triangle. Okay, these are your bases, and now in on your formula chart, on your text formula chart or your star formula chart, it has the formula to find different formulas for the trapezoid, and it has a B1 and a B2. Those represent your bases. It does not matter which one is base 1 and base 2. It doesn't matter at all. So I'm just going to go ahead and label this one B1 and this one down here as B2 to identify both bases. Alright, and the midsegment, the length of this midsegment is equal to half the sum of the two bases. So to write that out is the midsegment is equal to half the sum. So we're going to be dividing something by 2, the sum of the two bases, the length of base 1 plus the length of base 2. This is what this means right down here. That's your formula for it. Okay? And I think if you remember in an isosceles triangle, the midsegment is half the length of the base. But because we have two bases, you've got to add those, and this is directly between the lengths of both of these. It's bigger than the smallest, but shorter than the longer one. Okay? So those are your rules for a trapezoid and an isosceles trapezoid. Plain old trapezoid, there's not a whole lot to know except that you have one pair of opposite sides are parallel. On the back side, we have a kite. Okay. Kite's pretty quick and easy. In a kite, you've got two pairs of consecutive sides that are congruent, but not the opposite sides. Okay? The side opposite this longer one would be over here. Obviously, those are not congruent. Your pair of congruent sides are adjacent to one another. They touch. So here we go. These two sides are congruent, not parallel, just congruent. These pair of sides over here are congruent, not parallel, just congruent. Alright, now where a short side and a long side intersect, that angle that's formed, that angle is formed to the one directly opposite it. Those are congruent. These other two are not congruent, and you can tell by looking. This one is much narrower than this angle right here. This one's bigger. We don't know what they are. All you need to know is that these opposite angles here are congruent. One pair of opposite angles are congruent. And to remember which ones, it's the angles formed from the two different sides. These two sides are different lengths. This angle is formed from congruent sides. This angle is formed from two congruent sides. Those are not equal. Alright. Then down here, if you are to draw your diagonals inside of the kite, the diagonals that are created are perpendicular. They do not necessarily bisect each other. However, it's not listed here, but the longer diagonal does bisect the shorter diagonal. And if you turn this sideways, you'll see that you've got right here a right triangle. Okay? And that these two right triangles are congruent by side, angle, side, because they share this side. So these two, in both of these triangles, so it's congruent in both of them. They both have a right angle, and then these two segments are congruent as well as these two sides here. You know they're congruent because that's the definition of a kite. You have two pair of congruent sides. So just some things to point out for you to be aware of, and if you want to go ahead and mark those, because you will be needing to know that and pull out that information to solve some of the problems in your homework. That's it. Thanks, guys.